looking at here is basically the last chapter 11 homework. We're ahead of the game, and that's because you didn't have Thursday off, whereas my other stats class did. So you're kind of a little ahead of the game, which is fine. All I want to get done today is finish off questions from the last chapter, estimating the difference between two means. And when we get that finished, call it a day, because it's a really nice place to finish. And that means both my classes are at the same place. It makes my life easier if we keep things balanced. I don't think you'll complain, right? So let's start with our first question. Are you looking at a double screen? Right. I found this to work. Now, if you've got a tiny screen, it might not work so well for you, but it's so much easier to have the question and then solve rather than this up, in and out, and then me losing the place because I can't remember where my windows are, right? So it's kind of helps me and hopefully indirectly helps you. So volunteers have been chosen to look into cold and how zinc helps. So any of these volunteers who had a cold within 24 hours were randomized, and I'm writing these numbers down. Zinc and placebo. So imagine you've got the cold, you're one of the volunteers, and they give you a pill. Take this twice a day. And then how many days did it take you, right, before your cold was over with, right, before you felt fine again? And I think what they're looking for is, does zinc help reduce the duration of a cold? Right. Now, I'm pretty sure it does, and that hopefully this evidence will prove it. And the reason I think it does is, if you go to Safeway and that, isn't there lots of over-the-counter things you can get if you've got the cold? And isn't one of them zinc? Have you not seen them? There's zinc pills. You know, they're not lumps of zinc, right? There's zinc in them. But I suspect that that's because if you take these zinc, you either won't catch the cold, or at least if you catch it, it won't last so long. So let's see if the data backs this up. So in this story, 29 of them took the zinc lozenges. So sample size is 29 for zinc. Read on a little bit more, and 21 were in the placebo group. So this is pretty much guaranteed to be a double-blind situation. The mean duration for the people who took zinc, so X bar for the zinc people, was that their cold lasted 3.2 days. And the standard deviation for that group that took the zinc was 1.7 days. On the other hand, the placebo group, their cold lasted 5 days, and that the standard deviation was 1.9. Okay, so I've just written all that down. You got all that from the story. We are going to do this one. Now, do you see that there's a word here that says pooled procedure? Notice that? Sometimes, most of the time, it's unpooled, but this is pooled procedure. Let's show you how that works. You click on salt, right? And you make sure that you're over here to the right, and you pick the inference one. To sample, check. Sample one is going to be the zinc people. So they took 3.2. Their standard deviation is 1.7. And there were 29 people in that group. And then the second one are the placebo group, and they lasted 5 days of cold. The standard deviation for that group was 1.9. And in that group, there was 21.
You might want to make sure your standard deviation for the top one is 1.7 and not 11.7.
Ooh, I hit one twice. Welcome. Now we're going to do confidence interval, and normally we would hit generate results. Most of the questions, that's exactly what you will do. If the data is not pooled, you generate the results. If they don't mention anything, you just hit generate results. If you're not sure, you hit generated results. But if they physically say pooled procedure, pooled data. Only in those terms, hit that guy. Now, I wish that box had been pooled data so that you would know, hit that box when it's pulled, right? But now that you know that's the box, when I hit generate results, do you see all the numbers are up here? But the one that we want is this fella and this fella. So the difference between the two groups is somewhere between negative 2.8 and negative 0.8. And always read the question, 2 decimal places. So 2.83 and 0.77. And that's all you're being asked to do in this question. I think it would have been interesting for them to say this. Is there enough evidence to prove that zinc tablets give you less days of the cold? Looking at that interval, that 95% interval, does that prove that the zinc tablet people have fewer days with the cold? Yes. How do you know that, Brendan? You're correct.
Because they're both negative, there's no zero.
Right. If you get an interval that's both negative, doesn't that mean the first thing is less than the second thing? The first thing is how many days you have the cold with zinc in this story, and the other one is placebo. Suppose both numbers were positive. Doesn't that mean that the first thing is bigger than the second, right? A different story. And they call it contains zero or has zero or something. When that happens, don't you get like a negative 2.8 and then a positive 1.2, right? There's a zero in it. And when that happens, isn't your conclusion there's not enough evidence to tell if there's a difference? It would have been nice if they'd added that. Right, here's our next story. None of you take alcohol, get hangovers, and if you're underage, you better not, right, Parker? I'm assuming you're underage, but I'm bad at judging ages anyway. So underage, under drinking age, right? Students answered questions about alcohol use and hangovers, including how many out of the list of 13 possible hangover symptoms they have experienced in a year. So dehydration, nausea, headache, loss of balance, I'm running short of ones, hair falling out, loss of memory. True story. I had a friend, still a friend, but I don't really have any contact with him back in Scotland. When I was younger, we would go to the pubs and, you know, hang out. And he was a really nice guy. But when he got drunk, you might know people like this, and we describe him in Scotland as a mean drunk. You ever had a friend who was a mean drunk? Eric, you had a friend that was a mean drunk? Yeah, they're not fun. He used to want to get into fights. He would insult people to try and get into fights. He was not a good guy to be around when he was drunk. And he wasn't very good at fighting, which is actually a bad combination. And so, you know, he would get drunk and he would get into his mean stage, and we all would protect him. So he would insult the heck out of us and we would just agree with him. And that didn't help any because he just get more annoyed at us. You know, if he went and said, yeah, you're right. Well, you got me there, right? And we tried to protect him, but sometimes we couldn't protect him and he would leave and go to another pub. And you'd see him the next day with a black eye or something wrong with him. And you'd say, what happened? And he says, I'm getting in a fight. And he also used to do, which is why he was a nice guy. Once he got drunk and he was mean, the next day, the next night when we met up, the first thing he did was apologize to everybody. And it was a kind of general apology, like, I'm sorry for whatever I said to you. You know, I was drunk. And I turned around to him once and I said, why do you bother? Why do you get drunk? And, you know, you're not the kind of person who should get drunk. And he just shrugged his shoulder and says, what are you going to do? And I thought, what a stupid answer for such a question. If I was a mean drunk and I kept on getting beat up, wouldn't there be a one brain cell that would say, just don't get drunk anymore? Well, you expect one brain cell to tell you that. Eric, your mean drunk friend, has he ever learnt that lesson yet? Or is he still a mean drunk? No names, I don't need to know.
Oh no, I knew most of them while I was in the military. So
So you don't know about them now. They may still be
really.
mean drunks.
could be.
Yeah. And back to our story then. You might have forgotten what this is about, but we're collecting data on mean drunks. Actually, we're not. We're collecting data on what kind of bad symptoms you get after being drunk. And it's two groups. First group, I'll call them men. The second are self-identified women. And we need to know sample size, mean, and standard deviation. So in this story, they're going to tell me everything I need to know. 470 men. So that's N. Scroll over a little bit for. And the mean number was, what, 5.4. 755 women, so that group was much larger. It was 5.2. And standard deviation for both of them was 3.7. Okay, when you tell me those 6 numbers, we are pretty much good to go. But let's answer the early question. Isn't the parameter of interest here the difference in the mean number of hangovers, which it is pretty much all the time, isn't it? X1 take away X2. Now, we want to get a standard error. We want to get a 95% and then a little guy at the bottom here. Right, to get any of these numbers, including the standard error, we go over here, and since this one is set up, all I need to do is change the numbers. So for the guys, is it going to be guys first? Yeah, I think it is. So for the guys, it was 5.4. Standard deviation was 3.7. Oops, one there. And sample size was a very healthy 470. On the women, it was 5.2, which is a fewer of those. And standard deviation was also 3.7. And the sample size for the women was 755. Right, now I'll be hitting the confidence interval button in a minute. In none of this story did they assume equal variance, or let's kick that one off. Can we just assume that they never mentioned pools? So I'm just going to do the blank version. I really think if you're not sure, which I'm not, I should leave it blank. If they physically say they pulled the data, I'm checking the box. If they don't mention it, I'm leaving it blank. How about that as a simple rule, right? If they say it, use it, and if they don't, don't. Do you think there's a big enough difference between 5.4 and 5.2 that is going to show up in this confidence interval? What's your gut feeling? Right? Brendan's thinking they're too close, there's going to be a minus plus interval, right? Any of you think it's going to be all positives, which means that men have more hangover symptoms than women, even if it's only a little bit more? Okay. I think it's going to be significant. Let's find out. And I'm wrong. So, standard error is this number here. Oops. Is this number here?
That's x1 minus x1 again. Shouldn't it be x1 minus x2?
It is. And guess what? It just shows you that even WebAssign screws up.
Oh, so that's a mistake. That's not.
Yeah, it's just a mistake.
Oh, okay. I was like, I wonder how to do that. Like,
I didn't even notice it because I kind of knew what it should be, so my brain just pretended I saw it. Right? Now, the confidence interval is negative this guy. So the difference could be negative. On the other side, it's positive, so it could be positive. Check the question. They want this one rounded off to 2 decimal places. I probably asked this before, but I can't remember the answer. See if it wants it to 2 decimal places, but you give the answer to 6. Does WebAssign tell you you're wrong, or does it just let it slide? Has anybody done that by mistake and still got it right?
I don't know. They're very nitpicky about when you put in stuff like that. Because I was doing a question yesterday on, I think it was the single mean chapter 11 homework, and I rounded like earlier in the process up, and
right.
then it ended up being like in the 3rd decimal place, it was like off by 1, and WebAssign just didn't like that, and it said it was wrong, and it was actually a very frustrating process. But eventually I realized it was because I had rounded earlier, and I just like shouldn't round until the very end. I should just assume there's like 4 decimal places.
Even if you need, that's a true thing. If you're doing something by hand, especially by hand, if it's 3 decimal places, do your calculations to at least 4. Right, so round different than 4 when you multiply, add, subtract, and divide, and only when you've finally got the last number, right, the answer, then round it off to 3. So always be 1 decimal place ahead of it because of what Isabel just said. So it looks like it's been fussy. The good news is that when salt is involved, we not need to worry so much about that, because the number is what it is, and then we can round it off. Unfortunately, doesn't this interval contain 0? So there's not enough evidence, right? So it may or may not be that there's a difference. You see how they phrased it? May or may not be. To me, that's the same as there's not enough evidence to know one way or the other. Are we feeling more comfortable about how this salt thing is going to work with these types of questions? Right. So let's move on to a pretty standard question. Everybody here knows this, at least my wife will tell you if you meet her that it's true, that I have a big head. But here is someone who actually allegedly went to the trouble of proving it. So you can imagine that they were in a pub and one of them went and said, "Oh, you're a big head." And the other guy says, "You're right, I'm going to prove that guys are bigger heads than women." And as stupid as that sounds, the government gives money to some of the dumbest things in the world. They do. They count butterflies. People get money to count butterflies. Do you know how hard it must be to count a butterfly? Because they move. How on earth do you do that? 1, oh, no, that's the same 1, 2, whatever. People get paid money to do that. You're laughing. You wouldn't believe some of the surveys I've seen, right? So this guy at university got drunk one day with his friend, and he went to his university council and said, "I'd like some money to do a survey." And they didn't give him a lot, but he had 32 guys and he measured their heights. So the men, the circumference was 57 centimeters, right? So, put the tape around the forehead, you got it. And the standard deviation was 1.8. And somewhere in there, I forgot to write it down, there were 32 of them. And then they got some women. There were 32 women. Okay, that's interesting. And they had a circumference of 54.9. So guys are 57, women's are 54.9, and the standard deviation on the women was 2.2. So far, so good. Let's do salt. Put all the stuff into salt, then we can answer all of these questions or whatever we want, right? So that's set up. I'll assume it's men, take away women again. So guys are 57. standard deviation 1.8. And in the main
there's-
sample,
There's 32 of them. 57 is the mean. Isn't it?
yeah,
Oh, sorry. I
Oh.
thought you said that there was 57 of them. And I was like,
I
wait.
might have said that. You're right,
Sorry.
but thankfully I didn't
It
type
threw
that.
me off. I was like, wait.
So 54.9 is the women's average circumference of their head. A little bit more variation in that. And a sample of also 32. There's no mention, at least I can't see any, of pulling the data, so we'll leave it blank. And I'll generate the results. And in no particular order, 1.09 to 3.1 and change. Let's see what kind of accuracy they want. Nearest 10th, which is another way of saying 1 decimal place. Okay. Find the value of the difference between the two. 2.1. Is that number there? Find the standard error. That number there. Put that one in. Standard error. What kind of accuracy are you looking for? To nearest 10th. Oh, well, that's going to be pretty easy. Right. Again, they didn't do that little bit at the end that I would have preferred. Is there enough evidence to say that men's head are bigger than women's based on that confidence interval that we can see? Right. The difference between them is somewhere between 1.1 and 3.1. Is that enough evidence to say men's heads are bigger than women's? Right. So now when you insult a male, you can back it up with science. You're a big head. No, I'm not. Well, I have seen some data that suggests that that's actually provable. Are we good? Are we good with that question? Any questions? Let's move on. Can anybody remember how far we got the last time? Because I don't want to go through the same group. I know this one about colds seems familiar, but they've got at least 4 questions to do with colds, so they all look the same. This one, I don't think we did this one. We may have done the one before that, but I think we're good on this one. But, you know, you can tell me later if I'm wrong. So this is the same kind of story again about getting the cold or not getting the cold, right? How long it takes. They're going to be the zinc people, and there's going to be the placebo people. And they go in and tell you the usual kind of stuff. 25 took zinc. So there's 25 in the zinc group, and there's 23 in the placebo group. For the placebo group, 7.3 this time. And the standard deviation for the placebo group is 1.5. For the zinc, 4.1 days. The duration, the standard deviation was 1.4. Are we getting a deja vu with these questions? Aren't they basically read the story, get the numbers, plug it into salt, and answer some questions, right? So there is 4.1 for the zinc. Oh, wait a minute, should I check? Yeah, I'm pretty sure it's zinc against placebo. So 4.1, 1.4, and there was 25 in the zinc group. And second one is 23, 1.5, and 23. No mentioning anything being pulled. So just generate results. And that's not right. That is not right. Can anybody, I know what I've done wrong. Can anybody see what I did wrong?
7.3 for the sample mean. Not
Yeah.
anything.
Don't know why I said that. There we go. Generate results again. That's much better. So lower limit goes in here. Upper limit goes in here. They want the answer to 2 decimal places, so 0.4 rounds up to 0.5, and 35 stays as 35. Standard error is this number. And they want that one also to 4 decimal places, so 4197 becomes 4198, and the difference is negative 3.2. Are we all happy with these numbers and where we got them from? Pretty standard. That's what you get to do. Here we got one of those sentence things. Complete the following sentence. With a 95% confidence, we can say that the population of cold sufferers represented by the sample taking zinc lozenges would be increase or decrease. If you took zinc, did you increase or decrease the number of days you'd have the cold? Up?
Decrease.
Decrease, right? Less days. So reduce. So if you take zinc, it reduces the number. How many? Well, somewhere between 4 days. Oh, I have to be careful. I'm going to put in 2 different versions of the same answer. Couldn't I just repeat the 2 intervals? Right? But I think in this case, the way it's phrased, won't this be between 2.35 days and 4.05 days? And the reason I'm doing it that way is, haven't you also put the word, it's like a double negative, haven't you put the word reduced by somewhere between 2 and 4 days? Does that make sense? I get a feeling that's the way around that particular question gets phrased. But if I screwed up, don't have 5 shots, I just switch it back again. So I think I should be fine. Now, is the interval that we just calculated yes, it is evidence that the differences are different because it does not cover 0. Zinc lozenges appear to be effective at reducing the number of symptoms. You see how we put that sentence together? Call it good. How are we doing? This one does involve an extra button thing. It's a little bit different because right now I don't need salt because this table here pretty much contains the same information that the salt one that we did. In fact, it has numbers that we don't get in salt. Do you notice that there's a thing called SE mean? So that guy and that guy, can you just pretend? Shh, go away. Phone does it. Shouldn't they have a voice command in your phone called go away? Right? In fact, shouldn't they have a command go away forever so that however it was ringing you doesn't ring you again? Right. So where was it? Okay, right. So this guy is good to go, and it does have a use salt button, but we don't need it quite yet. But it will get used in, does it get used in any of these? Yes, it gets used when we get this thing called the multiplier. Right, which one of these 5 formulas is the one that you use to calculate confidence intervals? Is it number 1, 2, 3, or 4, or 5? Number 1. Do you recognize, if you go back and look at your notes, wasn't that the way we did it? What name do we give to the number x1 take away x2? What's it called again?
The parameter of interest.
It is, and it's also given another name. It's called the statistic, right? It is the parameter of interest, but it's also called the statistic. And if you go up here, the statistic, because we're talking about samples here, this is 0.8. Do you see where that 0.8 came from? Right? The statistic is the difference in the means, at least when you're doing samples, right? If it was populations, it would be difference in the means of the population as well. Now, standard error is not mentioned here. I know it's got these 2 guys. And couldn't we, if we wanted to use the standard deviations and the sample size and this really ugly formula here, and in 5 minutes calculate it? But I'm going to be lazy. I'm just going to go over here and put in that same data. The story behind this is they looked at 2 groups, doctors and professors, and they looked at the testosterone levels in the males. And for doctors, it was 11.4. I am going to mute things for a second. Once I find the right button.
I need your headphones.
And
I need your headphones.
We can't hear you. You muted yourself too, I think.
Professor, you muted yourself.
are we good now? You can hear me?
Yeah.
Yep.
Okay. Right, I need to focus, so let's get some jokes at my brain and that'll help as well. You know, I just said if I had a brain, I'd be dangerous. We have some really good insults in Scotland, and that's one of them. And we have other insults. I kind of like this one. If you get really annoyed at someone, you say, pick a window, you're leaving. Right. If you want to insult one by telling them how stupid you think they are, you say, if brains were explosives, you don't have enough to blow your nose. If you had half a brain, you'd be a half-wit. Just thought I'd throw those insults out there. Forgot what I was talking about. Right, I think I focused, right? I think we're ready to return back to the doctor's one. I use looking at the double screen now if I go and screw that up. We're still on the same screen, right? So they looked at these levels. So I'm about to put in the doctor's. So it's 11.4. The standard deviation is 3.37. The reason I'm doing this is so I can get the standard error. So that's the doctor's. Underneath that, we're going to do the professor's data. And so the sample mean is 10.6. Next door to the sample mean is the standard deviation, which is 2.54. And the sample size is very small. There's only 10 in it. And if I generate results, can you now see the standard error? Now, that isn't the only way that you could get the standard error. If you wanted to, couldn't you just do it by this calculation here? Right, you just go to your calculator, and what you would do is you would go the square root of 3.37 squared divided by 16 plus 2.54 squared divided by 10. And will you totally ignore this pair of numbers? They have nothing to do with what we're doing. That's just, what else? You know, the software may tell you other things that are not necessary for you to know for the questions you're being asked. If you wanted to know what that standard error there was, and that was that there, this guy 0.84 is what you would get if you took this guy and divided them by the square root of 16. And this 0.8 is what you would have got if you'd taken this guy and divided it by 10. And I should say the square root of 10, not 10. Remember S over square root of n, that guy. So if you want to know where those numbers came from, by that I mean these two at the end, that's where they came from. But they have no effect, don't matter, don't care, don't use them. And now we have one last guy, multiplier. When you do this formula up here, isn't this the statistic, right? The difference between them. Isn't this ugly formula the standard error? And didn't we call this guy the multiplier? Right. So now I have to show you how to get the multiplier. And that involves a lot of work. So the first thing I'm going to do is I am going to hit distribution calculations. I'm going to make sure it's T distribution. Degrees of freedom, do you see it there, 22? So I'm going to put in 22. I'm going to have to make this a full screen here. Right. 22. Which one of these 4 dots do you use if you want to get a multiplier?
Between.
The between, which is actually set up. And we wanted a 95, didn't we? So if you wanted a 99, you do that. If you want the multiplier for a 90, you do that. If you want the multiplier for a 95, you do that. And isn't this number the multiplier? And that's where that number came from. So you see, that was actually a totally different menu. When you do the multiplier, you have to go to distribution calculations, right? It's a different place, right? It's not the ones that we use to get the confidence interval, right? It's a different place. And then you go and you answer these 3 questions. So I'll put this on a full window. Interpret the confidence interval. With a 95% confidence, we can estimate that among the 16 doctors and the 10 universities in the sample, the difference in mean, that's not the one that's really here. With a 95% confidence, we can estimate that among all male doctors and professors, the difference is somewhere in that interval. Now, that might just seem like nitpicky, but isn't one, we're using this to predict everybody's difference, and the other one, it's only the difference between those two. So that's that one. And what assumptions are we making? We're making that assumption. When you use a T distribution, you don't care how small the sample is. Can't you do it even with 5 people, right? So that's not a problem. And we don't care if it's really skewed to the right. In fact, wasn't that why it was designed, for data that was really weird looking? So we don't care about that. The only thing we care about is that the samples are a fair representation, right, of the population. Now, based on this interval, which no longer exists, and I hope it will exist in a few seconds from now, based on this interval, negative 1.6 to 3.2, roughly, right? That interval there. Would you agree there's not enough evidence to show that there's a difference between the two groups? Doesn't that interval contain a zero? Right, it starts at negative 1.6 and it ends at 3.2. In fact, I think they tell you up there, don't they? Yeah, starts at negative 1.6, right, and it ends at 3.21. Are we cool with that question? Right, the only difference between that one and the ones we've done today was you had to do a bit more work to get the multiplier. Would you agree? Salt did everything else, but you had to do a little bit more work to get that one. Okay, does question 7 look familiar? Because I'm beginning to get to a place where I think it's familiar, but I don't know.
I think we did that one, but could you review it real quick?
Sure, I don't mind doing it again as long as it's helpful. I'm cool with that. It's pretty much a copy of the one we just did, right? But I think you've got to see it a couple of times because once isn't always good enough. In this story, 63 students in a start class used their other hand, right, their non-dominant hand, to write letters of the alphabet down. And so we ended up with two groups. 29 females, they did about roughly 12.4, and that was their standard deviation. And 34 males, they did slightly better, right? 13 and a half letters in that, whatever it is, 15-second period. Do you see this SE mean thing where you try and ignore those, just like the last question? They don't affect anything that we need to do. Would you also agree that there's a few other guys like, what the heck is this number and that number? Agreed? Don't care. They're nothing to do with what we're doing. So sometimes you have to look at a table and say, I don't need that, don't need that, that's nothing to do with me. So if we were focusing, isn't it these three guys here? Well, I can't because of the way it goes. 1, 2, 3, right? Sample, mean, standard deviation. Would you agree they're important? Would you agree the difference is important and that the interval is important? But everything else don't matter. So what is the mean number of letters printed by the females? That number. And they don't ask us to round it off, so I'll put the whole lot in. What was the number for the males? Well, it's that number. These are important numbers. We use them. Now, I could just subtract them, but since the calculation's done, can't I just say the difference is negative 1.08? So females did about 1 letter less than the males, allegedly. Now, the 90% confidence interval is this number. Up to that number. And they want this answer to be exact, so I won't change anything. Now, when you have this, can't you do the standard 95% confidence that the interval is somewhere between there and there? So just read those 4 and figure out which one that is. Now, the next one is visual. There are 4 pictures here. One of them is from negative 3 and a bit to about 1. Would you agree it ain't that one? Would you also agree it is this one? 1, 2, 3 and a bit, negative. And would you agree that's 1 and a bit-ish? And that would do the other side. Now, use the confidence interval. If you read this confidence interval, is there evidence to prove that there's a difference between the two groups? No. So males and females write just as quickly with their non-dominant hand, as males do, right? Very much don't matter. So one of these sentences is going to say that. Do you notice that they're all to do with zeros? Contain 0, bigger than 0, less than 0. If somebody's really quick at reading, because I'm not, especially when it's my eyesight. I've lost the question there, what's up here? Which one of those 5 basically says you can't tell?
The one that says, since the interval contains 0, we cannot say that for the population represented.
Okay, which dot is that?
Oh, hold on. The one that contains, it's the bottom one.
Okay, since the interval contains 0, we cannot say. Perfect, you got it, right? Are we good for that? Now, it says, find the value of the unpooled star. Ah, almost misread it. It says unpooled. Now, can't I build one of these guys again and get the standard deviation? So let's see if I can do that. I've lost the place. 12.448. This is the females, 12.448.
Done 112.
Whoa, thank you. 4.128. And 29. If we go for the males, then it's 13.529. And kill off that one. And then standard deviation is 4.364. And the sample size was 34. Confidence interval 95, because this book has no imagination. Do I check the assume equal box in this unpooled data question? Nope. Actually, I would have preferred it said pooled data, because that way I could get to do something, right? But we just leave it blank. So generate results, and the standard error is that number. When they ask you for the value of T star, isn't that just a different way of saying, find me the multiplier? Right, sometimes you just have to get used to what they call things, right? Because they call it more than one thing, right? Finding T star is the same thing as finding the multiplier. Now, since I can click on this, I think I've written down all the numbers I need, did I? Yeah, it's a 95%. Did they mention degrees of freedom? Because I will need that. 60, right? Do you see it's 60 degrees of freedom? So I should be ready to go then. Use salt. Well, would you agree I'm actually in the right place? Distribution calculator. T distribution. Degrees of freedom were 60. And make this 0.95. And, oops, I haven't got the right dot, have I? Which dot should I be picking? Between. We're getting comfortable with this. It's always in between. That means this guy. Oh, and there's our answer. So that is the multiplier, the T star, and 2 decimal places. Well, it's pretty boring because the 2 decimal places, it's still 2.00. That help saying it a second time? Right. Salt is your friend.
Yes, thank you.
Right? Look for, if you can use salt, I would suggest you should, right? I couldn't have done this question without salt, but couldn't have done the standard error without doing salt. When I just go back to the data and I would go the square root of that guy squared divided by 29 plus that guy squared divided by 34, right? And I would have got the same answer because it is the same thing. Any questions?